Today we're going to look at solving quadratic inequalities. With solving quadratic inequalities, it closely relates to solving quadratic or graphing quadratic inequalities because technically what we're doing, you don't have to write this, is we are looking at a graph of a quadratic inequality that's either been shaded inside of the quadratic function or outside of the quadratic function, one of those two. What we're looking at on this page is we're trying to see after that's been graphed, what part of this graph is either above the x-axis or which part of the graph is below the x-axis. Every part of this relates back to the x-axis. That's why for each of these questions, you're going to see that the inequality must be equal to 0, or pretty much there must be a 0 either on the left or the right-hand side of your inequality. So let's go ahead and start off with the steps. We're going to find the zeros. We're going to create a sign chart, which I'll show you guys what it looks like. We're going to use some test points, and then we're going to find our actual solution interval. So it's very important for you to know what exactly we're looking for so you can figure out what we're going to find for our answer. So for the very first question, this one is asking us to find or solve when x squared minus x minus 6 is less than 0. So the first thing we need to look at is first, is this inequality equal to 0? Technically it is. Okay, so now that it's quote unquote equal to 0, we're going to look at where the solution set is going to need to be. That's going to come from this inequality. This inequality is less than. Okay, well think of that on a graph. Is less than going to be above the x-axis or below the x-axis? This is going to be below the x-axis. And you're going to need to make a note. Should we include the x-intercepts, which are the zeros? Well, looking at this inequality, if I was going to include the x-intercepts, what would need to be there? The little line underneath the inequality would need to be there. So it would need to be less than or equal to. Since it's not less than or equal to, I'm going to make a note. We're going to include the values that are below the x-axis, but not the x-intercepts. We're not going to include those in your interval. So let's find our solutions, which are our zeros, and let's draw a sign chart. So for this, I'm going to set this equation equal to 0, and we're going to solve. Well, the easiest way for me to solve is to find two numbers that multiply to -6 but add up to -1. Let's see if we can factor this. Well, I can technically use positive 2, or not positive 2. Positive 2 and -3. Since your leading coefficient is a positive 1, we're going to write our binomials as x plus 2 and x minus 3, and we're going to set that equal to 0. In order to find your zeros, we need to make it equal, actual equal sign, to 0. So we're going to set, by the zero product property, each of the binomials equal to 0, and we're going to solve. That's one of your x-intercepts. Here's the other x-intercept. What I now need to do is step 2. Draw the sign chart, and we need to use some test points. Remember, we're trying to see where is this graph below the x-axis, and we're not going to include the x-intercepts. Technically, both of these are x-intercepts, but we don't want to include them in our final answer. So for our sign chart, we're literally going to draw a chart underneath it, and I'm going to make two spaces, one at -2, which is on the left side of 0, and one at 3, which is on the right side of 0. This is what I mean when I say use a test point. So in here, I need to figure out which points are to the left of -2, in between -2 and 3, and to the right of positive 3. These are all values, if I was to graph this, that would be on your graph. Well, let's not pick anything too crazy. Let's go to the left of -2. Let's use x equals -5. In between -2 and 3, let's pick x equals 0. And to the right of 3, which means that it's greater than 3, let's just use positive 5. You can use whatever numbers you want, but I'm just picking these values. Okay, well, let's actually see what we're going to do next. We know that we want to find for our solution values that are below the x-axis, so that means we need to look for negative answers. And we also want to find values that are not the x-intercept. Well, if they're not the x-intercept, they're not included in your solution set. Think about a number line and a solution set. What type of circle would you need at -2 and +3? Would you need open circles or closed if you did not want to include those in your solution set? You would need open circles. Those will not include these values in your solution set. Okay, so now let's actually use those test points. So with those test points, I'm going to look back at the original inequality. In this original inequality, we're going to take each of these x values that we just found, and we're going to substitute them in both of these spaces for each of the test points that we just picked. So down here, we're going to substitute this in. So we're going to have -5 squared minus -5 minus 6 should be less than 0. We're also going to use 0 squared minus, not 5, because 5 was on the last one, 0 minus 6 should be less than 0. And then 5 squared minus 5 in parentheses minus 6 is less than 0. On this portion, it's really important that you actually look at the values that you have and that you plug in your numbers using parentheses. It's the easiest way to avoid making mistakes. On each of these that I split up, all three of these we have to solve. So we're going to make this 25 plus 5 minus 6 is less than 0. 25 plus 5 is 30. And 30 minus 6 is 24. So you need to ask yourself, is 24 less than 0? No, it's not. This is false. So what that means is -5 is not going to be in your solution set. Since it's false, it's not going to be in your solution set. You are looking for true statements here. Okay, in the middle, 0 squared is just 0. Minus 0 is just nothing. So we have -6 is less than 0. Read that statement. Is that true or false? This is true. 0 is less than -6. So what that means is our solution set first is probably going to be in this middle section, in between -2 and +3. Let's check the last one. 5 squared is 25 minus 5 minus 6. 25 minus 5 is 20. And 20 minus 6 is 14. Okay, well, let's read this. 14 is less than 0. Is that statement true? No, it's not. This is false. So since that's false, you're not going to have your solution set in this area either. When you get true statements, that's where your solution is going to be. So your solution is going to be in between 2 and 3. Well, how would you write that in interval notation for our answer? Well, if you think about it, if I'm looking at a number line and I'm going to include all of this space, that's why I have my check mark, I'm including all of this space as my answer, all of this will be below the x-axis if I was to graph it. So I'm going to write my interval notation from -2 to +3. Why did I use parentheses? If you think back to what we graphed on the number line, the sign chart, we had 2 open circles. When you have 2 open circles, that means you're going to include parentheses at both ends, or at least one end. Wherever you see an open circle is where you're going to put a parentheses. So you don't have to graph this out, but what this means is for my graph at -2, +3, let's say this is what your quadratic function looks like, the solution set that you're looking for is below the x-axis. You're only looking for this space. For your homework, it would be helpful for you to graph this little guy out. Let's look at example 2. I'm not going to do example 2. However, I will at least get you started with it if you choose to do it later. Take a second and look at example 1 and example 2. They look the exact same, right? Yes and no. They have the same quadratic expression to the left of the inequality, but the inequality itself is completely different. One is the less than symbol and one is the greater than symbol. So what that means is if you were looking at the solution set for this, you would still use the exact same steps that we just used up here, but instead, for this question, you are looking for solution set values that are above the x-axis, and especially since we don't see that or equal to piece underneath it, we're also going to not the x-intercepts. If you choose to do this later, this is how you would do it. We're definitely going to do examples 3 and 4, and then we'll move on. For example 3, this one is asking for you to find for this inequality. It's already quote unquote equal to 0. So I need to go ahead and try to factor this if possible. And then I'm also going to see what the sign chart looks like. With this leading coefficient being positive or a -2, let's factor that out so that way it looks easier and we can solve it a little quicker. Whenever you have a negative leading coefficient, factor that out. So -1 parentheses 2x squared, the rest of the signs are going to switch. Plus 5x minus 3. And this is still going to be greater than 0, greater than or equal to. What we are trying to factor is this information in your parentheses. Okay, so let's make my little chart, because the first step is to find your x-intercepts, your zeros. We need two numbers that multiply to -6 but add up to 5. I can definitely use 6 and 1. The 1 is going to have to be negative. Since the leading coefficient in this parentheses is a +2, you do not write out both of your binomials as x plus 6 and x minus 1. It will not work. Instead, we're going to write this out as 2x squared plus 6x minus 1x minus 3. We need to factor by grouping. When I group the first two terms and the last two terms, we're going to have to factor out your GCF. Looking at the first two terms, I can factor out a 2x. That's going to leave in parentheses x plus 3. In the second group, no matter what, since this sign is negative, you're going to need to factor out a negative number. Well, between 1 and 3, you can only factor out a -1. That's going to leave in parentheses x plus 3 for your other binomial. So the two binomials that we're looking at are, I'm going to rewrite the entire inequality. We're going to have -1, x plus 3, 2x minus 1, and technically it should be equal to 0 since we're factoring. Since we are factoring this, and if you don't believe me, look back on the other page, we set it equal to 0, so that way we could actually solve it. So by having this equal to 0, the -1 is going to be useless. We don't need that as far as our answer is concerned. We just need to use the zero product property and set both of the binomials equal to 0. So we're going to subtract 3 here to give me x equals -3. And then we'll add 1. So 2x will equal 1. And then we'll divide both sides by 2. So x will equal 1/2. What we need to do now is we need to create a sign chart. So over here to the side, I'm going to create a sign chart. And from that sign chart, we're going to plot the coordinates, or not the coordinates, but the spaces on the number line for -3 and about 1/2. Don't panic when you see that fraction. It'll be a lot nicer in a second. We need to pick 3 points to test. To the left side of -3, in between -3 and 1/2, and to the right of 1/2. So think of some numbers you want to use. Okay, well, to the left of -3, I'm going to use -5. In between -3 and 1/2, I'm going to use 0 because you have to go through 0 to get to 1/2. And then bigger than 1/2, I'm going to pick 1. I don't need to go to 5 because I just want to avoid picking these values of the 1/2 and the 3. One thing I just realized I forgot to do at the beginning, I got so excited about factoring, was identifying what we're supposed to do here. Well, with the greater than or equal to symbol, there's 2 things you need to write out. Greater than means you're looking for values that are above the x-axis, and you want them to include your x-intercepts. Why are we including the x-intercepts here? Well, because of this or equal to symbol. We are going to include the x-intercepts, both of them. So on this graph, I want values that are above the x-axis. Well, what does that mean? That means that all of the answers we want should be above. They're positive. The next thing we want to look for is including x-intercepts. So if we want to include x-intercepts, we need to use a closed circle. So at 2 and 3, or 1/2 and -3, I'm going to put a closed circle here and a closed circle here. You want to include those. Even though I'm looking for values that are above the x-axis, I still want whatever statement I get down here at the bottom to be true. That's the whole point of solving it. So let's take the original inequality at the very top and we're going to substitute it in. So from that original inequality, we have negative 2x squared minus 5 times negative 5 plus 3 should be greater than or equal to 0. Negative 2 times 0 squared minus 5 times 0 plus 3 should be greater than or equal to 0. And negative 2, 1 squared minus 5 times 1 plus 3 should be greater than or equal to 0. Each of these is what I need to solve. Whatever true statements I get is where my graph is going to be. Pause the video now and solve it. Where's your solution set? This will give me negative 2 times 25 plus 15. Ooh, not plus 15. Plus 25 plus 3 is greater than or equal to 0. That's negative 50 plus 25 plus 3. Negative 50 plus 25 is negative 25 plus 3 is greater than or equal to 0. And negative 25 plus 3 is negative 22, which is greater than or equal to 0. Is this statement true? It's not. This is false. So our solution set cannot be to the left of negative 3. In the middle, I have 0 squared, which is just going to be multiplied by 2. That's just going to be 0. 5 times 0 is just 0. So I have 3 is greater than or equal to 0. Let me look back at the top. What was I looking for again? We're looking for all of the values that are above the x-axis. So if you're looking for values that are above the x-axis, this will work. This is true. And then the last one is if we have negative 2 times 1 minus 5 plus 3. We're going to have negative 2 minus 5 plus 3 is greater than or equal to 0. Negative 2 minus 5 is negative 7. And negative 5 plus 3 is going to give me negative 5 is greater than or equal to 0. Is that statement true? We can't include the right side of 1/2. So our solution set, we only want values in your solution set that are above the x-axis and include the x-intercepts. That is going to be between 3, negative 3, and 1/2. And especially since we have closed circles here, I'm going to put 2 brackets at both ends. This is your answer. All right, next piece. So looking at example 4, we're going to, this one didn't copy correctly. Make sure on your paper that this is the greater than or equal to symbol. Okay, so on here, first issue that I see is that this is not a 0 on the right-hand side, of your inequality. So we're going to have to add 1 to each side. So we're going to have 3x squared minus 6x plus 1 is greater than or equal to 0. Of course, you can pause it and solve it if you want, but I'm going to go through it, especially since once we get to this point, I'm going to need a factor. 3 times 1 is 3, and negative 6 is at the bottom. Well, hold on a second. Positive 3, negative 6. The only multiples of 3 are 1 and 3. That's it. No matter how much I try, I'm never going to get negative 6. So unfortunately for us on this question, you cannot factor. Since you cannot do, so this is something you can't do, we're instead going to have to use quadratic formula. Whenever you get to a problem that cannot be factored, think back to solving quadratic equations. You're going to need to solve it using quadratic formula. So we're going to set A equal to 3, B equals negative 6, and C is positive 1. First, we're going to find our discriminant. So we're going to use B squared minus 4AC. Your B value is negative 6 squared minus 4 times A times C. This will give me 36 minus 12. And 36 minus 12 is going to give me 24. Technically, you're going to have 2 real solutions. because it's positive. Well, let's use quadratic formula to find it. If we need more space for this question, we can always use the back side of the page. So x is going to equal negative b, be careful here, plus or minus the square root of 24 all over 2 times a. Always double check that your leading coefficient here is positive when you're using quadratic formula. If it is negative, factor out that negative first so that way your answers that you get won't have a negative in the denominator. It makes your life easier. So we're going to make this x equals 6 plus or minus. I can simplify the square root of 24. If I simplify the square root of 24, that will give me 2 and 12. 2 is prime. 12 will break into 6 and 2, which break into 3 and 2. If I was to simplify the square root of 24, I'd have 2 times 2 times 2 times 3. Since the index on this radical is an imaginary 2, I can group one group of these 2's together to help them escape. All I am doing is simplifying this radical. That's it. So we're going to make this 2 square root of not 3, but 2 times 3, which is 6. So up here at the top, I'm going to replace square root of 24 with 2 square root of 6, all over 6. Okay, well, if you look at all of these numbers, 6, 2, and the other 6, you can reduce them. 6, 2, and 6 are all divisible by 2. So x is going to equal 3 plus or minus 1 square root of 6, which is just square root of 6, over 3. These are my answers. Well, these aren't the most beautiful answers that I've seen before, but we can still make it work. We're still going to graph this on a number line. But for a question like this, you would need a calculator. So I'm going to calculate these values for you. We're going to find the value for x plus the square root of 6 over 3 and 3 minus the square root of 6 over 3. I think I said x minus the square root of 6. Let's try this again. We're going to find two values. 3 plus the square root of 6 over 3 and 3 minus the square root of 6 over 3. We need to find what both of those decimals are supposed to be. So I've used my calculator. The positive, or when you're plus or adding that numerator, you're going to get approximately 1.816 for that decimal. And for this one, you're going to get approximately 0.183. We'll say 4, because technically it's 0.35. Let's make it 4. So now that we have these values, let's look at your number line to see where they're going to be. So the 184 is going to be to the left side of this graph. So 3 minus the square root of 6 over 3, which is approximately that 0.184. And then to the right of that is going to be 3 plus the square root of 6 over 3, which is about 1.816. So let's zoom in on this and look in. Okay, well, I need to pick some values that are to the left and to the right. Okay, so this was at 0.184. So if I wanted to pick a value that's less than that, pick 0. We can use 0 here. You can technically use -1 if you're too afraid to use 0, but literally this value is a little bit bigger than 0, just by a little bit. So I think you can get away with using 0 here. For the other one in the middle, okay, so we're looking in between 0.184 and 1.8. Well, honestly, in between those is x equals 1, just positive 1. And then on the other side of this, we can just use x equals 2, because remember, this decimal here is 1.8. So even though these answers look disgusting, we can still find the rest of this. So back at the top, like I forgot to do yet again, I'm going to look at my inequality. Okay, well, if the greater than or equal to, this means, again, you need to look above the x-axis, and you also need to include the x-intercepts. So by putting your answers above, that means that all of the answers we're looking for should be positive, of course with a true statement, but it should be positive. And by including the x-intercepts, we need a closed circle on each of those, C-I-R-C-L-E. So I'm going to put a closed circle here and here. And now we need to figure out, using the original inequality, we're going to use this inequality since it's already quote-unquote equal to 0, and we're going to find our answer. So over here, we're going to plug in, and I probably need some space. I'm going to break these into 3 spaces. So we're going to have 3 parentheses, 0 squared minus 6 times 0 plus 1 is greater, not less than, greater than or equal to 0. Let me double check that it was plus 1. Yes, it was. I'm making 3 different sections here since I don't really have that much space, and I'm going to solve them individually. We have 3 times 1 squared minus 6 times 1 plus 1 is greater than or equal to 0. And then lastly, we also have 3 times 2 squared minus 6 times 2 plus 1, and that should be greater than or equal to 0. In the first one, 0 squared is just 0. When you multiply anything by 0, it's still going to be 0. 6 times 0 is 0. So we have 1 is greater than or equal to 0. Is that statement true? Yes, it is. This is true. Since it's a true statement, to the left of this graph is going to be our answer. So it's one part. Let's look in the middle for 1. 1 squared is just 1, so 3 times 1 minus 6 plus 1. 3 times 1 is just 3, minus 6 plus 1. 3 minus 6 is negative 3 plus 1. And negative 3 plus 1 is negative 2. Is negative 2 greater than or equal to 0? No, that's false. So in the middle of this graph, we're not going to include that. Below, for positive 2, do it before I do. What is your value? We have 3 times 4 minus 12 plus 1. 3 times 4 is 12 minus 12 plus 1. 12 minus 12 is just 1. Well, 12 minus 12 is 0, but you're just left with a 1 on the left-hand side of this inequality. This statement, again, is true. So for this interval notation, think about it and write it. What would your answer interval notation look like? We're going to go from the far left. So if you're starting from this side over here, you're starting from negative infinity. And you're going to 3 minus the square root of 6 over 3. And you're going to union that to the other side. Before we union that, we need to put 2 things, a parentheses around the negative infinity and a bracket around the ugly fraction. From the other side, we're going to skip all of this space in between negative 3 and square root 6, negative 3 minus square root 6 and negative 3 plus square root 6. We're going to skip all of that space and just pick up over here and go all the way to infinity. So we're going to make this bracket 3 plus the square root of 6 over 3 to infinity. That is your answer. Last question we're going to look at before we try the ones at the bottom is question number 5. For question number 5, there's nothing to change here. Let's go ahead and look at your inequality first, since I remembered this time. Looking at your inequality first, you were looking for where this graph is above the x-axis, since you have the greater than or equal to symbol. And since I said or equal to, you need to include the x-intercepts. I-N-C-L-U-D. Okay, looks wrong. Include the x-intercepts. You know Miss Tapia can't spell, so include the x-intercepts. Just like we did before, we're going to have to factor. This one is a lot prettier and a lot quicker than the last one. If I was to factor, I need to find 2 numbers that multiply to 9 but add up to negative 6. We can only use 3 and 3, specifically negative 3 and negative 3. So we can rewrite this as x minus 3 times x minus 3 equals 0. Remember, I'm setting it equal to 0 because we're finding the zeros. Technically, we could write this another way. We can rewrite this as x minus 3 squared equal to 0. I don't care which way you solve it, either the first or the second, but both of them will give you the exact same answer. So I'm going to use the second one here since we haven't used the square root method, and we're going to use the square root method to solve this. Well, since it's equal to 0, I'm going to square root both sides. So x minus 3 is equal to 0. You don't need to put the plus or minus because 0 is just 0. And then we're going to add 3. So the x-intercept that I'm looking for is at positive 3. That will be included in your solution set. So over here to the side, we're going to use a pen and we're going to write this out. We have positive 3 in the middle. When you only have one x-intercept, it actually goes by a little quicker. You just need to pick two practice points or test points and plug them in. You don't need 4 of them or 3 of them if you don't have it. So we're going to use x equals, let's use 0 on this side and x equals, 5 on this side. We're going to take the original function to substitute in our values. This is what we're solving. The 0 cancels. 6 times 0 cancels, so we're left with 9 is greater than 0. If you're looking for values that are above, you want them to be positive. If you're including the x-intercepts, you want a closed circle. So at 3, put a closed circle. And keep in mind, we're looking for anything that's above, so anything that's positive. With this 9 being greater than or equal to 0, perfect. That's actually what I want. This is a true statement. So that means we have our answer on this side so far. 5 squared is 25 minus 30 plus 9 is greater than or equal to 0. This will become negative 5 plus 9. And negative 5 plus 9 is 4. That's true as well. Okay, well, that's wonderful. If I have a true statement on both sides, that means you're going to include all of this space over here and all of this space over here, plus the x-intercept. How would you write your answer if it's going to be everything? You would write that from negative infinity to positive. That would be your answer. Let's say, just for funsies, let's say that instead of being greater than or equal to, you were looking for less than or equal to. Less than or equal to would mean that you're looking for the values that are below the x-axis. You don't have to write this. But for the below part, you're looking for any values that are going to be negative. Well, if you looked at both of these statements, neither of those are going to be negative. You have 9 is less than or equal to 0, because remember, I flipped the inequality really quickly. That would be a false statement. 9 is not less than 0. So you wouldn't be able to use this space. And for the other one, you wouldn't be able to use this space. So if you can't use either side, what would you use instead? Well, the only answer you would have for that one is just 3. That would be the only answer. So literally, if that was the other case and this was less than or equal to, you would just put x equals 3, and that would be your answer. That's it. When you're doing these questions, guys, use your brain. Again, make sure you are actually reading the question to see what you're trying to find. Okay, let's look down at question number 6. This one is a little different and it's missing an inequality. So the first thing we need to do is see, okay, well, which inequality would be best to use? Okay, well, this actually, as it's written, is a domain restriction because of this square root. So if I don't give you an inequality, assume that I'm trying to tell you of some domain restriction. If you look back in your notes to domain restrictions, which we did at the beginning-ish of the school year, domain restrictions only apply with fractions and with radicals, specifically even root fractions, or even root radicals, excuse me. When you have 0 in your denominator, this means that you're going to have an undefined space of your graph. We'll talk about fractions more with domain restrictions towards the end of the school year. With even roots, though, we'll actually start that very soon. For even roots, you're pretty much having one part of the graph, which technically this graph up here represents that even root. There's one part of the graph that doesn't exist. There's literally no part of this orange graph to the left-hand side of the y-axis. So what it's saying is you can't graph anything over here, so please don't try. That's what we're looking at for even roots. So if you look back at the notes that we were just doing, this is an even root. This has an index of 2. So what this is trying to say is the domain restriction, all of this needs to be greater than or equal to 0 because you never want any negative values. So down here, no negative numbers. So because of that, we're going to write that out as greater than or equal to. This is what we're solving. And I'm going to make a little note. This is a domain restriction. So for this, I'm going to figure out how to solve it. Okay, honestly, guys, by having something being square rooted, what's the opposite of square rooting? You can square it. By squaring both sides, I'm getting rid of that radical. I'm not getting rid of the domain restriction, but I'm getting rid of the radical so I can actually solve it. And luckily for us, by squaring both sides of this inequality, it's not going to change anything. The inequality sign is not going to flip, and you're not going to change any of the numbers or signs. All you're doing is really just getting rid of that radical. This is the same thing we've just done. So for this question, we're going to factor it. We're going to make this positive 12, positive 7. The only two values I can use are 4 and 3. Since the leading coefficient is a positive 1, I can write both of my binomials as x plus 4 and x plus 3. And this is technically equal to 0 since I'm trying to find the x-intercepts. We're going to set x plus 4 equal to 0 and x plus 3 equal to 0. That's not a 3, that's a 4. So x will equal negative 4 for one of the x-intercepts, and x will equal negative 3 for the other one. Keep in mind, we're about to make a sign chart. Before we make that sign chart, look at the original inequality. This inequality means that you're looking for values of this graph that are above the x-axis and that are going to include the x-intercepts. So if you're graphing this out, we're going to have negative 4 and negative 3. If you're going to have it above, you're looking for positive values. And if you're going to include x-intercepts, you need to have closed circles here and here. So let's take some values and substitute them in. Before you guys do it, I'm not doing it. Before you guys do it, we're going to substitute in x equals, to the left will be negative 5. Keep it simple. Usually in between these two values, you can usually pick 0, but unfortunately negative 4 and negative 3 are literally 1 unit apart. So unfortunately for this one, you're going to have to use a decimal. So negative 3, negative 3.5. And then to the other side, you're going to use x equals 0. Let's figure out what your answers are going to look like. For this, instead of using the radical function that we have as the original, we're going to use this guy to substitute in our answers. We want to see if it's going to be greater than or equal to 0. We already know the domain restriction, which means you don't want to have any negative answers in here, but negative solutions, I'll say. So that's what we're trying to avoid underneath that radical. We don't want any negative solutions. So looking back over here, we're going to substitute in what we have. So we're going to have negative 5 squared plus 7 times 5, negative 5, plus 12 should be greater than or equal to 0. Negative 3.5 squared plus 7 times negative 3.5 plus 12 should be greater than or equal to 0. I need to move that just a bit. 12 should be greater than or equal to 0. And then the last one is 0 squared plus 7 times 0 plus 12. We're going to make this 25 minus 35 plus 12 is greater than or equal to 0. 25 minus 35 is negative 10. Negative 10 plus 12 is 2. This is true. For negative 3.5, negative 3.5 squared is going to give me 12.25. 7 times negative 3.5 is going to give me a negative 24.5 plus 12 is greater than or equal to 0. Okay, so we're going to subtract 12.25 minus 24.5, which is negative 12.25 plus 12 is greater than or equal to 0. When you combine both of those, negative 12.25 plus 12 is just 0.25. Negative 0.25 is greater than or equal to 0. All that work, and this is false. That's not going to work. All that stress for the middle, the last one's really simple. 0 squared is nothing. 7 times 0 is nothing. So we just have 12 is greater than or equal to 0. That's true. So remember, what we were looking for is all of the values that are above the x-axis and include the x-intercepts. Write out your answer. What is this going to look like? I'm going to put mine at the bottom. Your answer is going to be from negative infinity to negative 4, bracket, union, negative 3 to infinity. This would be your answer. These steps that I'm doing are literally the exact same steps you would need to do for questions 7 and 8. So in an effort not to waste time, I'm going to help you with setting it up, but that's about it. Just like number 6, they both have a domain restriction for 7 and 8. You do not want them, especially since it's an inequality, or not an inequality, a radical. You don't want any part of that graph to have any negative values underneath this radical. If you think back to this problem, if I was to plug in that negative 2.5 under there, it's telling me that you would probably get an undefined part of your graph. So on this page, you want this answer to be greater than or equal to 0. And same thing here for question 8. You want this one to be greater than or equal to 0. These are just kind of bonus type questions and extra practice to kind of challenge you to get you where we know you need to be. If you have any questions, send me a message.